We have a force time graph. So we'll do an Oizerga analysis. Origin is there. Y-axis is force in normal units. X-axis is time. Force, time. So any questions about force and time we'll read. The gradient is delta F over delta T, which is the rate of change in force. And the area is F delta T, which is J. And delta P is M delta V. And those two things happen to be equal to each other. We see that there is a constantly increasing force. The rate of change in force is constant. And if we were to skim to the end here and just say, what is the object's speed after the force has been applied for 4 seconds? So we can see there's a 4 seconds here, and it's going to probably relate to this change in momentum. But we do need to read this question because the context matters. So we have a 2 kilogram object traveling across a horizontal surface. We'll set that as positive. This is negative. 2 kilogram traveling across at 6 meters per second. A force increases at time is then exerted on the object. We should be wondering at this point, is the force that way or is the force that way? Which one is it? Except the force is given as a positive sign, so it suggests it's this. But we just arbitrarily decided to have it moving to the right. The graph of the force is shown. The applied force is in the direction of the object's displacement. So now we know it's in this direction, the same as the velocity. Frictional force is negligible. So we're given that the initial speed is 6 meters per second. And the area is going to give us the change in momentum. So let's find the change in momentum. We have a value of 16 high by 4. And so 16 times 4 is 64, divided by 2 is 32. So the change in momentum is 32. And that is equal to mv minus v0. And the mass we know is 2. The change in momentum is 32. We don't know the final velocity, but the initial velocity is 6. So we'll divide both sides by 2, and we have 16 equals v minus 6. Adding 6 to both sides, and we get v equals 22 meters per second. Choice B.